Last time we studied variance formulas for the 2 random variable case and the 3 random variable case. In these formulas, x's are random variables, w's are just non-random constant coefficients, some numbers you already know. Okay, they are not random. Let's look at the 3 random variable case. What is the variance or risk of the linear combination of random variables x1, x2, and x3? How can we expand this variance? Well, according to this formula, there are a bunch of variance terms, variance of x1, variance of x2, and the variance of x3, each having its own constant coefficient, which is now squared, w1 squared, w2 squared, and w3 squared. And then there are a bunch of covariance terms, the covariance between x1 and x2, covariance between x2 and x3, and covariance between x1 and x3. And each has a coefficient which is equal to 2 times the coefficients of the 2 random variables. If you have a good instinct or intuition, you should be able to well guess what the formula should look like if there are n random variables. So now we have random variables x1, x2, x3 up to xn. What is the variance of the linear combination of the n random variables? Well, there are variance terms, each having its own coefficient that is squared, and then there are a bunch of covariance terms. By the way, if you are not familiar with this capital sigma, it's summation notation, and there are many good YouTube tutorial videos that explain this notation, so I put just one of them I found here, but you can easily find such videos and study them. It's not very difficult. Basically, this first sigma notation means you should sum up this expression for I equal 1 through n. This second sigma notation indicates that you should sum up this 2wi, wj, covariance xi, xj, this entire notation for all combinations of I and j such that I is smaller than j. So if there are only 3 random variables, for the n equal 3 case, you have 1 and 2, 2 and 3, and 1 and 3. Okay? I don't necessarily think that you have to remember the last formula, but the most important point of these variance formulas is that as long as you know all the risk information about individual random variables, that is, as long as you know all the variances and covariances of individual random variables, you can compute the variance of any linear combination of those random variables. Okay? That's the important point of these variance formulas. Now, if you have a little knowledge about matrix algebra, this complicated looking formula and its computation becomes much clearer and easier. So now let me explain that. For that, as preparation, first you have to put the risk information you have in the matrix form. So you know all the variances and covariances of n random variables. First, you should put these variances and covariances in the matrix form. Okay? That's n by n matrix. The diagonal elements are variances of these random variables, variance of x1, variance of x2, variance of x3, up to variance of xn. Okay? Diagonal elements are variances, and then off-diagonal elements are covariances. The 1, 2 element is the covariance between x1 and x2. 1, n element should be covariance between x1 and xn. And 2, 3 element, for example, should be covariance between x2 and x3, and so on. Okay, first, you put all the risk information about individual random variables you know in the matrix form, and then this matrix is called variance covariance matrix, and it's denoted by, let's denote it as capital V. Once you get the variance covariance matrix, which is n by n, then the variance of a linear combination of n random variables turns out to be equal to the product of three things: the vector of coefficients in the form of a row vector times V, the variance covariance matrix we made in the last slide, times, again, the vector of coefficients, which is now in the form of a column vector. This expression, in turn, can be written in an even simpler form of W transpose times V times W, where W is just the vector of the coefficients. If you are not familiar with matrix addition or transpose or matrix multiplication, there are many excellent YouTube tutorial videos. So I put some of them I found here. Watch them, study them. They shouldn't be too difficult. The important thing here is that this a little complicated looking formula, the right hand side of this formula, is expressed as a very simple sandwich form. Basically, you sandwich the variance covariance matrix for the individual random variables by the vector of coefficients. Okay? Let's look at a numerical example. Suppose there are three random variables x1, x2, and x3, and suppose that the variance covariance matrix for these three random variables is given as this. So 131 is the variance of x1, 58 is the variance of x2, and 24 is the variance of x3. For off-diagonal elements, 46 is the covariance between x1 and x2, 27 is the covariance between x1 and x3, and finally 15 is the covariance between x2 and x3. As an example, consider a linear combination, such as this: 0.2 times x1 plus 0.5 times x2 plus 0.3 times x3. Question: what is the variance of this linear combination? You can use that sandwich formula. Here, the coefficient vector is just 0.2, 0.5, 0.3. And you sandwich this variance covariance matrix with the coefficient vector in a row vector form and the same vector in the column vector form. Okay? And after that, it's just matrix multiplication. Here, I first compute V times the second W, and then I multiply the first W to the outcome. If you proceed, you eventually get 38.84. So that's the variance of this linear combination. Okay? I have some exercise for you. Suppose there are three random variables x1, x2, and x3. Their means are given by a mu vector, 3.5, 4.5, and 7.5. And their standard deviations are given by a vector of sigma, 2, 4, 8. So 2 is the standard deviation of x1, 4 is the standard deviation of x2, and so on. The correlation matrix is given by this. Okay, so the correlation between x1 and x2 is 0.53, correlation between x2 and x3 is 0.39, and so on. Question 1. Find the variance-covariance matrix. Question 2. What is the expectation and variance of the following linear combination of the three random variables, 0.2 x1 plus 0.5 x2 plus 0.3 x3? What is the standard deviation of this linear combination? I'll post the answer in the future, so please give it a try.